Alright, in this video we will be going over integration by parts, which is an integration method used for certain integrals that you cannot use any other method, such as the reverse chain rule for. And generally these are integrals that involve two terms multiplied together, and you must break apart these terms to be able to solve the integral. So the way we do this is that we take the integral of fx dx and change it into the integral of u dv, therefore breaking apart the two terms into the u and the dv. Then when we take the integral of u dv, we get u times v minus the integral of v du. And we apply that formula to the problem after figuring out what u, dv, du, and v equal.
Okay, so the first problem we're going to do for you today is the integral of x cosine x dx. Now, when doing integration by parts, one sign that you can integrate it by parts is that there's two things multiplied together. In this case, we have x times cosine x. So now I'm going to pick a u value and a dv value. My u value in this case is going to be x. My dv is going to be cosine x.
dx.
Yeah, dx. And in order to find my du, I'm going to take the derivative of x and be left with 1 dx. In order to find my v value, I'm going to do the integral of the dv. So the integral of cosine x is dx is sine x. Okay, so now I have all my parts right here, and I can go on and apply these to the formula. So the first part of the formula is u times v, so that's going to be x times sine x minus the integral of v du. So sine x dx. Okay, and now you can see that I have a very easily solvable integral right here. So we're going to go ahead and solve that. So the integral of sine x dx is negative cosine x plus c. Now I'm just going to simplify my signs right there. And my final answer is going to be x sine x plus cosine x plus c. And that's a basic integration by parts problem.
Some integration by parts problems require that you apply the formula more than once. In the case of when you get an integral, the first time you apply the formula, you get an integral from the second part of the formula that you must then apply the integration by parts method to. And usually that comes when you have one of your terms is x squared or something greater than magnitude of 1. And it's important that you choose the right u and the right dv, because in this case, with the integral of 3x squared times e to the x, if you chose e to the x as u, you take the derivative and it would just be e to the x and you wouldn't get anywhere. And also if you put 3x squared in the dv and integrated, you'd get x cubed, which is a higher order of magnitude, and you have to try to go to the lower order of magnitude. So that's why you can't just pick any u and any dv, it has to be the right choices. So in this case, we pick 3x squared as u.
So 3x squared is our u, and our dv is going to be ex.
dx.
dx. So now, in order to find our du, we're going to take the derivative of 3x squared. That's going to leave us with 6x dx. And our v value is going to be the integral of e to the x dx, which is simply ex, or e to the x. So now we're going to apply that formula, uv minus the integral of v du. So u times v is going to leave us with 3x squared times e to the x minus the integral of e to the x times 6x dx. Now notice that this integral cannot be solved using anything other than integration by parts. So this is normal. We're just going to do integration by parts one more time on this problem. So we're going to find our u value is going to be 6x, which would make our du the derivative of 6x, just 6 dx. It's always good to be making things smaller. Getting rid of x's is a sign that you pick in the right values. So our dv is once again going to be e to the x, squeeze in a dx, you get the point. So then the integral of e to the x dx, our b value, is going to be e to the x. So now we're left with 3x squared minus, and I'm going to apply integration by parts. So our u times v is going to be 6x times e to the x minus the integral of v du. So our v is e to the x, and our du is 6 dx. Okay, so now we have an easily solvable integral and we can complete this problem. So our final answer is going to be 3x squared e to the x. I'm going to distribute my negative minus 6x e to the x plus the answer to this integral. 6x e to the x dx is simply just 6 e to the x plus c. So that you're left with your final answer, 3x squared e to the x minus 6x times e to the x plus 6 e to the x plus c. And that's just a two-step integration by parts problem.